In this video, we're going to look at geologic folds. So folds are one type of geologic structures that form because of deformation as a result of stress being applied to our rocks. For the most part, folds are going to form because of compressional stress. I'll show you some examples where they're not, or when it's kind of strange sort of stress as well. So folds are a result of plastic deformation. If you remember, plastic happens when the rocks bend and they stay bent. And these are all different types of folds. And you can see these are all different types of scales as well down in the middle here. This is an entire mountain. It's one single fold. Versus on the picture on the left, these are teeny tiny little folds, and there's a pocket knife for scale. So these form at all sorts of different scales. So just to make sure we are clear on some terminology here. So a fold has a limb. So the limb is the kind of tilted over sides of your fold. The hinge line is sort of where that folding happens. And then the axial plane cuts that fold in half, or relatively in half, depending on the shape of the fold. And I'm going to be using some of these terms as we go. So I want to make sure you knew sort of what those sound like and what they look like. So our first kind of fold is an anticline. An anticline is an arch-like shape in which the limbs dip away from the hinge line. So in this case, the hinge line goes right up the middle here, and you can see they're dipping away. This is a cross-section of it. It looks kind of like a rainbow. If you notice here, this gray rock is going to be the oldest rock. The dotted ones are a little bit younger. The white one's a little bit younger. And this other kind of grayish rock is by far the youngest. If you look at it in a map view, it actually makes stripes. And we're looking at this kind of at an angle, so they're not always angled over. But it's going to make stripes. In the middle of it, that stripe is going to be really old. And the younger stripes are going to be on the outside. So an anticline always has the oldest rocks exposed in the middle on a map view. And this is assuming that top of it is eroded down too, so don't forget that. Now remember, I talked a little bit about thinking about the 3D-ness of these things. So if we look at this other cross section, it just looks like two horizontal layers. But we got to take that cross section the other way to be actually able to see the shape of it. So how are you going to form these? How are you going to make a rock bend like this? You squeeze it. So these are a consequence of compressional stress. If you want to know where the word comes from, anti, so just the prefix anti means opposite, and cline means, it's a Greek term that means to lean. So in this case, they lean in opposite directions, or they go away from each other, which kind of makes it easy to remember. Anticline makes an A shape in cross section, and in an anticline, these strike and dip symbols point away from each other. That's a nice, easy way to remember all of these. Here's an example of an anticline. This is what it actually looks like. This is a pretty nice one. Again, this is a cross section. This is the easiest way to recognize those. And this cross section is just a road cut. Those are our beautiful man-made cross sections. So if you have an anticline, there's an opposite of an anticline. That's a syncline. And in a syncline, it's an arch shape in which the limbs dip inwards and towards each other. Syn means together, cline means to lean. So they're leaning together or towards each other, which is kind of cool, right? And if you look, the strike and dip symbols both point inwards and towards each other. Now, a syncline makes a smiley face because synclines make me smile. I don't know. You can try it. I like that one to remember it by. Now, since this is the opposite of the anticline, the rock ages work the same way. Here is your oldest rocks, a little bit younger, and the youngest rocks are actually exposed down the middle of our geologic map. So in the syncline, the youngest rocks are in the middle, and the oldest rocks are on the edges. And again, the strike and dip symbols point towards each other. So here is that example. We looked at this already once, didn't we? This is one of the examples in the previous video where we were comparing strike and dip symbols. This is another beautiful road cut showing you a syncline. Now, how are you going to make, what kind of stress is going to form a syncline since it's the opposite of an anticline? Well, this is compression too. All right, this is one that gets confusing, but they both form because you squeeze rock. Now, one thing you should know about anticlines and synclines is they're almost never alone, because when you squeeze rocks together, it tends to fold up accordion style. And when it does, what you get is an anticline and a syncline, and an anticline and a syncline, and an anticline and a syncline. And in all these, you can see that anticlines and synclines start getting kind of weird shaped too, and it all depends on kind of how it's end up folding. But you can see this light colored rock is really resistant. So that makes mountains here, that makes mountains there, that makes mountains there. And the brown rock is a lot more easily weathered and eroded. So it's going to tend to make valleys. But in this case, the right limb of the anticline is the left limb of the syncline. But all of these are just squeezed together. Here are a couple of examples of some folds that are a little bit weirder. So you can see here is an anticline, and right next to it is a syncline. They're all sort of tilted over just a little bit. And here's an anticline, but he's almost laying over on his side. So these are sort of examples of how those can be shaped. Now the most perfect sort of example is these symmetrical folds where it just goes syncline, anticline, syncline, anticline. There, if one direction sort of pushes more than the other. So if there's more stress coming from the right than the left, it tends to make them a little asymmetrical. If there's a whole lot more, you get overturned. In this case, you're overturned and you're recumbent fold. So this is when it's actually laying over on its side. But these are the cases where the oldest rock isn't always at the bottom. So if you look, the youngest rocks are this light gray color. If we were to cut it over, there's actually younger rocks on top of that because it's been folded over. So there's an example of where the law of superposition doesn't always work, but it almost always does. Now, in all those examples I've been showing you, the hinge line of the fold was horizontal. So everything just folds straight down. That's why I make stripes on a geologic map. But life is never that easy. So if you look at this fold, this is an anticline. It's been folded over, but it's also been tilted backwards. So this is called a plunging fold, where your fold axis isn't horizontal anymore. Now, sometimes you can see actual mountains that look like this, or little hills that look like this, but most of the time what happens is the top of this is eroded off, and it looks more like this. All right, so you have plunging anticlines, plunging synclines, but this is a nice look at actually what it looks like on a geologic map. So if we take the top of that one off, on a geologic map, a plunging fold, the fold actually has U or V shapes. Now don't get these confused with the cross sections. All right, there's ways to tell kind of from the shape of it if it's an anticline or syncline from the top. But the most important thing is to look at the age of the rock. In this case, you have old rock, younger rock, younger rock, younger rock, which means oldest is in the middle here, so it has to be an anticline. Now here's a beautiful example of a plunging fold. I showed you this earlier on. This is Sheep Mountain, Montana. So this is one mountain that is an entire plunging fold by itself. So what kind of fold is this? Is it a plunging anticline or a plunging syncline? So we can use some of the clues around here to figure this out. But the easiest one is if you look at these layers right here. Can you see how they're tilted over this way? So if I'm drawing strike and dip symbols, the strike and dip symbols are going to point to the left. Over here, it's a little harder to see, but these rocks, particularly here, are plunging or folded, and they're tilted to the right. So if those are pointing away from each other, that has to be an anticline. Here's another type of fold, a monocline. What does mono mean? Mono means one. Remember, cline means to lean, so there's only one side that's leaning. So a monocline is an arch-like shape that has only one dipping limb versus two, like the other ones we've already seen. So in cross-section, it starts out nice and flat, and then it dips down, and then it becomes flat again. So if you look at the rock, this cross-section from this direction, it just looks like nice layers of rocks. But from this cross-section, you can see that kind of smushed down sort of S shape to it. In the map view, you're going to have stripes going down of younger and younger rocks as you walk towards the direction of dip. And if you remember in the other video where we were looking at examples of strike and dip symbols, we actually had one of a monocline. So here's you a little diagram from, I believe, your textbook of a monocline. Sometimes why these happen, it's called a drape fold. So there's actually a fault under there. So the fault is where the rocks move brittly, but the rocks above it are just kind of happily bending. So a little more plastic deformation on top. And so the fold drapes over that fault. It's often how we see it, not always, but often. So in this case, the monocline, it's really hard to tell a stress without looking at those faults. Here's an example of a monocline. It's one of the more famous ones in the U.S. This is in Mexican Hat, Utah. If you look, these rocks right over here, nice and horizontal. They dip down really steeply, and these are called hogbacks. And then it flattens out again out here in the plain. And if you ever drive through Mexican Hat, you actually drive down the dip, which is pretty amazing. One last set of folds. In this case, these are circular folds. So a dome is a circular fold that has the oldest rocks in the middle. But if we look at, so it's like a dome shape. Think of like a dome football stadium. This is what the rocks look like. And then that top is eroded down, and this is what you have left. In this case, all your strike and dip symbols point away from the middle, because if you are standing on the top of the University of Phoenix Stadium on the dome and you trip and fall, you're going to slip outwards, right? So you're going to fall around the edges. So all of those strike and dip symbols point radially away from that center. In cross section, it actually looks just like an anticline. A lot of times it's not, you don't have really steep arch. It's a very broad arch. But it does, sometimes these are actually called circular anticlines. Now, a basin is another word for like a sink. So think of the basin of your sink. When water runs in, the point is for the water run to the middle. So that's where the strike and dip symbols point. All the strike and dip symbols point towards the middle. And these, if you pick one rock layer, it's actually shaped just like a bowl is. In this case, the middle of it has the youngest rocks and the oldest rocks around the edges. And in cross section, this looks like a syncline as well. So sometimes these are known as circular synclines. Here's a couple examples of these beautiful folds, at least on a geologic map. So over on the left, this is, I believe, like up in the Cheyenne River. I think it's up near my Wyoming, maybe. So here in the middle, you can see it's mostly bullseye shaped. That's an easy way to recognize these on a map. So this is mostly bullseye shape. You've got this central crystalline area. Then you have limestone. Then you have sandstone. If we look at that cross section, that granite's oldest, and then you have schist, and then you have sandstones that are piled on top of it, and they're beautiful dome shape. Now sometimes these can be formed by, like, remember a laccolith actually pushes the rocks up around it, or possibly what I'm going to say is this granite intrusion actually probably pushed everything up too, which kind of messes with your oldest rock in the middle, but remember this is an intrusion, so it messes with that anyway. But your schist is definitely going to be older than your limestone, and the limestone is going to be older than these sandstones on the edges. Over here we have the Michigan Basin. Pretty much the entire state of Michigan is one big basin. So if you look, this is a great thing to look at those ages of the rocks on your knowledge check, or when I'm testing you how well you know these things. I'm often going to give you just a map with a key. Now, where do we find the youngest rocks on this key? Youngest rocks are always at the top, oldest rocks are always at the bottom. So if we look at the center of Michigan, that's got the youngest rocks. And as you go away from the center of Michigan, things get older and older and older and older. Beautiful basin. Here's a great example of one of these. This is a Rychat structure. It's in Mauritania. It's called the Eye of the Sahara. This sucker is enormous. It shows up really nicely on satellite images. And especially debated for a long time what this was. Was it a volcano? Was it some sort of weird impact structure? But what they've kind of decided is if you look at the rocks, they're all tilted. And it's really hard to see, but those are tilted away from the snow structure. This is just a dome. Alrighty, so there are your folds. And remember, you should know how to recognize them in map view and cross section. You should know where the oldest and youngest rocks are. You should be able to draw the strike and dip symbols. You should know, at least for anticlines and synclines, what type of stress forms them. And then obviously if you know the stresses, you know which type of plate boundary forms them as